Hi guys, so yeah, this is a GTX780 3GB GPU. Yeah? It's one of 10 graphics cards I bought off eBay in auction. So they got 10 cards, and he had a starting bid of £100, and I was the only bidder. So this is the list of the 10 cards. Yeah, you can see. One of them interestingly says it's a fake 1050 Ti, and one says an unknown small GPU. Now, when these turned up in the post via Hermes, they took like 11 days from when they sent them to arrive, and I was in like the UK for 4 days, and my wife was there for 9. And basically, they turned up. It wasn't his fault. It was Hermes. They kind of like disappeared for 8 days, couldn't even track them. They issued a claim code and then they turned up. So unfortunately, by this point, my wife, I was already back in, the wife couldn't put any more weight really, so she managed to get 5 of them in. So the little ones here, this one, the ones with the ticks on, yeah, are actually here. The other 5 are still in the UK, and I don't know whether to pay to post them over to here or whether just to leave them there, because probably myself or my wife will perhaps go back in January. Maybe I'll decide what to do about them. Yeah, so that's what I paid in total, 100 plus 950 postage. Yeah, and he says, well, gaming graphics cards 10, all spares or repairs, some display a picture in the BIOS, and no further testing. So it'd be interesting to see with the 5 that I have here, which we can look at over the next few videos, and let's see if that actually matches what we've got, and what that might suggest is the likelihood of the other 5, yeah, which are in the UK. I don't know what this means as unknown memory, whether he doesn't know how much capacity the memory is, or whether it's some sort of error it comes up with. But since he says he only tested the BIOS, I suspect he just doesn't know how many gigs of memory that card has. Maybe he doesn't really say, yeah, or not clearly. Anyway, enough waffle. So this is the card, yeah, Zotac. So I'm not going to plug this in. The first thing I'm going to do is actually open it up and have a look, check the physical condition of this first, and then make some resistance measurements looking for shorts, yeah? And if that all looks okay, then we'll power it up and let's see what it actually does. So first of all, I'll open this up and then let's have a look to see what we can see actually inside this, yeah? Okay, so I've got it apart. Cable soldered a fan assembly on, so yeah, I only had to take the 4 screws out of the back of the, basically, which was around by the GPU actually, and it came off then, yeah. It looks quite tidy actually. I mean, the heatsink compound is gooey, it's not too dry. Don't see any obvious issues. Oh yeah, I see a broken coil here. That's interesting. Let's just zoom down and let's have a look. Yeah, so this is obviously broke, yeah, here. I suspect this is probably just a filter, so you've got the fuses, and I think these are probably filters. I don't think this is part of a buck regulator, but if it was, I'd have to change it, because having a chunk of the former missing is probably decreased the inductance of this. I'm sure it would do, yeah, and by doing so, effectively it would mess it up. So possibly this, when it magnetizes in the VRAM, it would effectively just saturate and effectively become like a short circuit at that point, yeah, and blow some MOSFETs, and generally not be a good thing to have going on, yeah. These are all 16 volt capacitors, and I'm suspecting this is probably just connected to the 12, and probably this one as well. We have a buck regulator here, well, we have another coil here, and some power supplies. I mean, I'm just looking at it now, this is probably the PEX, sorry. This is probably the PEX, the 0.9 volts, I guess, yeah. These are probably the V core, and maybe this is VRAM, I'm not sure about this one here. And without taking this heatsink off, which I could do actually, I mean, three screws hold that in place. So I'll check some resistances first, and if I'm kind of happy with what I see, I might just give this a a try then, yeah? So first thing, let's look for short circuits on the primary voltages. So these are the voltages coming into the card, yeah, which is 12 volts, which is on the first three fingers here. The fourth one in from this end is 3.3. Then obviously we have the two 12 volts here. And it's possible that these are feeding different phases, like one might be the VRMs for the V core, might be for the VRAM, or it may be like half and half, you know, they do various. Sometimes you get some of these phases powered from down here, yeah. So what we need to do is check for shorts on all of the incoming voltages first. Okay, I'll zoom out a little bit, I'll get the meter ready, let's have a look. Okay, I can actually get the meter into the shot here, so I don't need to use the inset camera, so you can still see me. I'm sure the meter's probably more interesting to look at. Okay, so these coils here, first of all, let's just figure out which side of these connectors is actually grounded. I'm just behind the inset. So one side of these would be ground. You would think, wouldn't you? Meter's going a little bit mad on that one. That's not, isn't. Yeah, okay. So this is the ground, yeah. So the 12 volts though on the underneath ones, yeah. Is this connected to one of these? Yeah, that's connected to the 12 volt coming in straight through. So this is just a filter, so I'm not too worried about that at the moment. I doubt that would cause any problems actually. The other one's probably connected to the older one of these. Yeah, are they both connected together? Sometimes they are. No, no, they're not. So this 12 volts is coming through this one, and this 12 volts is coming through this one. I suspect because I'm reading to here, the fuses must be okay. Let's have a look at these two fuses. Yeah, sure they will be. Let's have a look. Otherwise, I'd have no connectivity to here. Yeah, these then just look like capacitors that are on the 12 volt rail. So then we have the other coils. Yeah, this one may be a 5 volt supply. I mean, I don't know these cards, to be honest with you, so I can only just kind of like suppose a little bit, but I'm guessing this might be a 5 volt supply. And it looks okay. It's a high resistance. Yeah, these two in here, 60 ohms. That's probably the RAM. Oh, I shorted to the heatsink. That's why I did that. 60 ohms is almost certainly the RAM, yeah, which is under this one. Let's look at this one. Probably the same, probably wicked together. 60 and 60. I'm guessing the V core on this is going to be low, but it might be an ohm or something like that. Let's have a quick look. 6 ohms, so this is the continuity, but not on diode mode, on resistance mode. Yeah, let's have a look. 6 ohms. That seems okay. This one is probably the 0.9 or 1 volt supply PEX. 190 ohms, that's fairly high. Again, I just touched the metalwork then. The metalwork is grounded. 192. So I don't see any shorts there. And I'm thinking maybe this supply up here is 1.8. Let's just see if that's actually a linear regulator, an LDO. Let's have a look as well at the just the resistance on the 12 volts coming in here as well, and then we will check this one. So no short there. I'm sure that's ground. It's definitely ground, yeah. So there's no short on the 12 volts coming in. Let's look at the 3.3. Yeah, that looks okay. So yeah, so this little chip here, I think this is probably the 1.8. Let's have a quick look at it. Okay, I'm not sure it is exactly that. It's something a bit like that, but I'm not sure it actually is that. It's a high side load switch. Outputs on, well, 6, 7, 8. Well, we can just have a quick look around here for shorts. I don't think we'll see anything. Yeah. So this is the output side of it. There's just a high resistance here. And this is the input side. Yeah, there's no shorts around that. Okay, so I think we can actually plug this in and let's just see what it actually does. Okay, so it's ready to go. I've just popped the analyzer card in as well. I've got a little bleeper on the power switch. So let's just put the power on and then let's see what this actually does. I've just put the heatsink back on with 2 screws just for the moment to see what this actually does. Yeah, as soon as he says somebody's actually give a picture in the BIOS, we'll get one bleep out of it. Yeah. But that could be it's just detected the onboard video. And I've got no video coming out of this. Yeah. Nothing coming out of it. So, okay, let's get the extender and let's have a look to see what we've got in the way of voltage on this. Yeah. It's obviously not going to power up by the looks of it. I'll just give it a little bit longer, but I don't think it's going to boot any further than that. And I'm guessing if I connect the VGA to the actual motherboard, it has onboard video. I've probably got a picture coming out of the motherboard, yeah, like it's not detected the card. Just put that in there, let's have a quick look. No, actually I don't have. Just switch it off again. Power it back up again. Doing one bleep. Well, interestingly, I don't have any video coming out of the onboard video. I don't have any video coming out of the GPU either. So it's like it's kind of detected it and disabled the onboard video by the looks of it, but it's not giving us a picture. Okay, that's interesting. Let's just power it off. I'll just make sure the actual test rig's actually working. Yeah, you never know. I've not used it for a couple of weeks, so sometimes things go wrong in the meantime. Yeah, you don't really realise it. Okay, put it over there. Let's just go once again, just make sure our actual test rig is actually working. Okay. Looks like it's gone a bit further now. Yeah, so one bleep and I do get a picture. Okay, I suspect, yeah, it's just set, you know, no bootable device, which I don't have on at the moment. Don't have a hard drive. So, yeah, I think he's possibly detecting that card but not giving a picture. Let's get the extender out and let's see what voltage we've got on it. Okay, so I've just used the little mining adapter, the single channel PCIe one. I've got the graphics card powered up from my ATX power supply rather than the bench power supply, just because it was easier, basically. So let's have a look to see. Once I connect the power cables, yeah, just get these on. Now let's have a look to see what we're actually getting on in the way of voltages. So we're ready to go. Let's just start it up, and then first of all, we'll check vehicle. Something not switched on. One moment. So yeah, there we go. Okay, so let's have a quick look at vehicle first, yeah, which will be on here. So I've got vCore. It's not particularly hot at the moment. I've got vCore. This VRAM. Looks like I haven't got that one on the wrong side. Okay, so just switch it off. I don't want the thing to get too hot. So I've got vCore. I'll just check the VRAM again. Just 1 second. I can see where to make the connection to it now. So, VRAM is here. And that's got nothing on it, yeah. That's got a 0.8. That's PEX 1 volt, yeah. What's this one? 12 volts on that one in actual fact. Little one over here, 5 volts, yeah. So we seem to have everything apart from the VRAM, which in actual fact is the last voltage to come up on these cards. So we need to have a look around that to see if this is being enabled, yeah, and where that comes from. Okay, so this, I think, is the VRAM supply. There's a couple of reasons for that. Main one initially is the fact that if we look at the resistance on this voltage rail from the coils, we have about 60 ohms, and that's typical for VRAM, yeah, on some cars. I mean, it can be as low as 30. I've seen it very low on some unusual cars, I think. And it goes to these capacitors here as well. You can see it's also on there. The other good indication this is VRAM is that if we go from top of the capacitor or one end of the coils, yeah, and we look behind where the RAM chips are, there's a lot of capacitors around here, yeah. And if we just try one of the larger capacitors and just see if that connects to these coils, basically. So it's a bit awkward to do, but get 1 meter probe on the coil or on the top of one of these capacitors, yeah. As good a place as any, because you know that is on the same as a coil. Well, let's have a look on these capacitors behind the RAM chips, yeah. Let's get a connection again, let's have a look. And if we find it comes somewhere here, it looks like it probably does. Slipped off here. Just to show how awkward this can be to do sometimes. Yeah, let's go back again there. And let's have a look again on here somewhere. Yeah, it goes there. Yeah, you can see it. So it goes to capacitors which are mounted behind the RAM chips, and there's a pretty much certainty that's where it's going to. Yeah, it's for the RAM. So it looks here like we've got 2 MOSFETs or something similar, and a good guess this chip which is nearby is probably the VRM for these, and this one or this one is probably the VRM for these, yeah. So let's have a look under the microscope and let's see what we've actually got here. Okay, so we've got 2 what look like MOSFETs, and we've got 2 coils. So we've obviously got 2 phases here, yeah. You'll hear the bleeper on the meter, but I'm sure these 2 phases will be connected together. Yeah, you can hear it, yeah, I'm sure. So they're connected together, and there's only 2 of these, so the chances are these are actually dual MOSFETs. One is driving each coil, and each of these will have 2 MOSFETs in them, yeah. The port number is 4901NF, yeah, and that's probably been driven by this. Oh, in fact, yeah, this looks like a gate pin coming off there to me, and it looks like it goes straight down here to this chip. Let's have a quick look. Oh yeah, it goes there. I bet these are test points, yeah. Yeah, it goes to the chip, okay. So we can say pretty much straight away that these are probably dual MOSFETs and this is the controller. Now we can look at this part number here, this 4901NF, yeah. The other one is this chip. Now this one, yeah, has this rather strange markings. You may have seen these before if you've worked on this stuff. So it says OT equals FF. Yeah. When you see markings like this with the equal sign in, it's often made by a company MPS, Monolithic Power Systems, yeah. And basically the letters before the equal sign is usually the model number of the chip, yeah, and will refer to the part number, and the numbers afterwards, the letters afterwards and the numbers are some sort of date code, like FF353 is a date code, yeah. So OT is the one we want to be looking for. So let's have a look on the internet. Let's see what we can find out. So we can first find these dual MOSFETs, which I'm sure that's what they are. So 4901NF. Right, found that easily. Yeah, data sheet on semiconductor. This is the thing. And it's a dual N-channel MOSFET, which what I thought it would be. Yeah. So you can see that the gates are on pins 1 and 8. And effectively this acts as a high side and a low side MOSFET all in one package. So the coil will come from the junction here, yeah? The buck regulator coil. So that's that one. Now we've got this strange looking thing. So the way to find these normally is put MPS as the manufacturer, yeah. ON in this case was the code, sorry, OT was the code, yeah. And then what you think it is. So book regulator or book controller. Let's see if I find something. Okay, so it's found this MP8860. Now this, let's have a look. This I don't think is the right chip. First of all, there's only one coil, and I'm sure I was just driving two coils. Yeah, that's the first reason I don't think it's the right chip. And the second reason, this is definitely not the right chip, as ours, if you look under the mouse here, I'll show you again, has more pins. This has 16 pins, and I'm sure ours has 6 down each side, which is 24 pins. So I can say that with good confidence that is not the right part number. Let's have a look at it again at ours, and we know at least now where the gates are on these MOSFETs, yeah? So on pins 1 and 8, and maybe we can work out what this thing actually is. Okay, so here's our dual MOSFETs, yeah? Just have to zoom that as far as it'll go. So we know that pins 1 and pin 8 are the two gates, yeah? This one's the other way around, pin 1 and pin 8. So let's have a look to see where these go on our controller chip, yeah? So pin 1, the first one, yeah? Pin 1. Connection, there we go. Let's see where that goes to. It looks like it must go down here somewhere. That goes here. No, I've shown a bit of resistance to that pin actually. Just make sure I'm on it properly. Maybe I was on the MOSFET not properly, yeah. Okay.
Hello.
Hello.
Morning.
Okay, so these are the two dual MOSFETs, yeah, and the gates are on pins 1 and pin 8, and the other one's upside down if you like, pin 1 and pin 8, and those will go to this chip, yeah, and we can see that's the case. So for instance, this is pin 8, and you can see it comes down and it goes somewhere into here, yeah. Just get a connection on it. Yeah, it's there. Yeah, so you see it goes onto the chip, yeah. Now this chip, I honestly don't know what the data sheet is for it. I'm not sure what it exactly is. But what I do have is a schematic for a GTX780, which is gigabyte. So it's not the same as this, but we can have a look to see if that's actually similar to what we've got here. So let's have a quick look. So this is the schematic. This one, yeah, this is gigabyte N780 3 gig DDR. So this is basically hopefully similar to ours, although this card we have is Zotac, yeah. We often find that the different manufacturers of these are basically the same. And this page, FBVDDQ, this is basically the RAM power supply, and we can see obviously it's quite similar to ours. So there's two phases, 1 and 2 here, yeah. And this gives FBVDDQ, which is the power supply for the DDR, the memory basically, yeah. So we can have a look and see what chip is driving this. Now this chip is RT8611. That's a Realtek chip. Ours is an MPS chip, I know that much. But this chip, if you look at it, appears to be a 24 pin chip, which kind of matches ours, yeah? And we've got some dual MOSFETs here, which may not be the same as ours, but again, it kind of matches. So we can see that one pair of MOSFETs, which is one package, the high gate is on pin 2 and the low is on pin 23. So if we make a note of that, 2 and 23, and then we can look at the other one, yeah? This is the other one. So you've got 17 and 20, yeah? So you've got 2 and 23, 17 and 20. If the gates of our devices connect to the same pins on our chip, it's probably the equivalent of this, yeah? So let's actually have a look to see if that's actually the case. So 2 and 23, 17 and 20. So this is the first of the two MOSFETs, okay? Here, this one. And we can actually have a look to see. So we know the gates are on pins 1 and 8 from the data sheet that we found for this chip. Yeah, so sorry, these dual MOSFETs. So there's pin 1. So let's see where that actually comes into our chip. This is pin 1 in the corner where the arrow is, yeah. And that actually goes to pin 2. Okay, pin 2. So if this is like our circuit diagram, this should go to 23, and actually it looks like it probably does. 6, 12, 18, 24. So 23 is going to come in here. Yeah? And it does. Just get a connection on it, but I'm sure it does. So it just slipped a little bit there. This helps us if I'm looking down the microscope. Okay, so 223. So the other one then, which is up here, should be on 17 and 20. So this is pin 1 on this one by the dot. So let's have a look on pin 17. So 17 is going to be up this side. 18, 17. Is it here? That's not there. Maybe that is the other gate. No, okay, let's go back to this one. So pin 1. And pin 20 is going to be somewhere here. Coming around this side. No. Does it go down this side? Is this one going to 17? Have I got a connection on it is another good question. Ah! Just didn't have a connection on the MOSFET, yeah. So yeah, that's pin 17. So the other side then, which is here, we expect this to go to pin 20, yeah? Which is kind of in the middle of this lot somewhere. 18, so 19, 20. Yeah, it's there. It's that one. Okay, so the two MOSFETs connect to the pins on this chip that matches that schematic, which means that schematic is probably at least similar to what we have on our board. So let's go back now to that schematic and see what else we can check with this. The most interesting thing here then, or the thing I'm most interested in, is enable, pin 3. Yeah, so pin 3 is enable. Pin 15 is VCC. This is power to the chip, yeah. So VCC is 15. Enable is pin 3, I think it was. It's just got off the screen now. Just made a note of them. Oh, the browser seems to have gone a little bit crazy. Let me just close down some of the... Yeah, maybe something just crashed in the browser, you know. Go away. Well, that's just typical, guys. The browser seems to be acting up somewhat. Let me find this again. Okay, so it's here. At last, the computer's working, yeah. So, 15 is VCC. 3 is enable, so we're interested in them, yeah. These two MOSFETs, the power coming into the top one should come from 12 volts. So we'll see that here somewhere, yeah. Yeah, 12 volts, yeah, into that one, and the same with the other one, yeah. So we can look if we've got 12 volts coming to the MOSFETs. We can have a look to see if we've got VCC on pin 15, and we can see if we've got enable. Probably that's all this chip needs to actually start up, yeah. Okay, so let's get us connected back into the computer and let's actually measure some voltages. Okay, so these are the two dual MOSFETs, yeah, and the gates are on pins 1 and pin 8, and the other one's upside down if you like, pin 1 and pin 8, and those will go to this chip, yeah, and we can see that's the case. So for instance, this is pin 8, and you can see it comes down and it goes somewhere into here, yeah. Just get a connection on it, yeah, it's there. Yeah, so you see it goes onto the chip, yeah. Now this chip, I honestly don't know what the data sheet is for it. I'm not sure what it exactly is. But what I do have is a schematic for a GTX780, which is gigabyte. So it's not the same as this, but we can have a look to see if that's actually similar to what we've got here. So let's have a quick look. So this is the schematic. This one, yeah, this is gigabyte N780 3 gig DDR. So this is basically hopefully similar to ours, although this card we have is Zotac, yeah. We often find that the different manufacturers of these are basically the same. And this page, FBVDDQ, this is basically the RAM power supply, and we can see obviously it's quite similar to ours. So there's two phases, 1 and 2 here, yeah. And this gives FBVDDQ, which is the power supply for the DDR, the memory, basically, yeah. So we can have a look and see what chip is driving this. Now, this chip is RT8611. That's a Realtek chip. Ours is an MPS chip. I know that much. But this chip, if you look at it, appears to be a 24-pin chip, which kind of matches ours, yeah. And we've got some dual MOSFETs here, which may not be the same as ours, but again, it kind of matches. So we can see that one pair of MOSFETs, which is one package, the high gate is on pin 2 and the low is on pin 23. So if we make a note of that, 2 and 23, and then we can look at the other one, yeah, this is the other one. So you've got 17 and 20, yeah, so you've got 2 and 23, 17 and 20. If the gates of our devices connect to the same pins on our chip, it's probably the equivalent of this, yeah? So let's actually have a look to see if that's actually the case. So 2 and 23, 17 and 20. So this is the first of the two MOSFETs, okay? Here, this one. And we can actually have a look to see. So we know the gates are on pins 1 and 8 from the data sheet that we found for this chip, yeah? So sorry, these dual MOSFETs. So there's pin 1. So let's see where that actually comes into our chip. This is pin 1 in the corner where the arrow is, yeah. And that actually goes to pin 2. Okay, pin 2. So if this is like our circuit diagram, this should go to 23, and actually it looks like it probably does. 6, 12, 18, 24. So 23 is going to come in here. Yeah? And it does. Just get a connection on it, but I'm sure it does. So it just slipped a little bit there. This helps us if I'm looking down the microscope. Okay, so 223. So the other one then, which is up here, should be on 17 and 20. So this is pin 1 on this one by the dot. So let's have a look at pin 17. So 17 is going to be up this side. 18, 17. Is it here? That's not there. Maybe that is the other gate. No, okay, let's go back to this one. So pin 1. And pin 20 is going to be somewhere here. Coming around this side. No. Does it go down this side? Is this one going to 17? Have I got a connection on it is another good question. Ah, just didn't have a connection on the MOSFET, yeah. So yeah, that's pin 17. So the other side then, which is here, we expect this to go to pin 20, yeah? Which is kind of in the middle of this lot somewhere. 18, so 19, 20. Yeah, it's there. It's that one. Okay, so the two MOSFETs connect to the pins on this chip that matches that schematic, which means that schematic is probably at least similar to what we have on our board. So let's go back now to that schematic and see what else we can check with this. The most interesting thing here then, or the thing I'm most interested in, is enable, pin 3. Yeah, so pin 3 is enable. Pin 15 is VCC. This is power to the chip, yeah. So VCC is 15. Enable is pin 3, I think it was. It's just got off the screen now. Just made a note of them. Oh, the browser seems to have gone a little bit crazy. Let me just close down some of the... Yeah, maybe something just crashed in the browser, you know. Go away. Well, that's just typical, guys. The browser seems to be acting up somewhat. Let me find this again. Okay, so it's here. At last, the computer's working, yeah. So, 15 is VCC. 3 is enable, so we're interested in them, yeah. These two MOSFETs, the power coming into the top one, should come from 12 volts. So we'll see that here somewhere, yeah. Yeah, 12 volts, yeah, into that one. And the same with the other one, yeah. So we can look if we've got 12 volts coming to the MOSFETs. We can have a look to see if we've got VCC on pin 15, and we can see if we've got enable. Probably that's all this chip needs to actually start up, yeah? Okay, so let's get us connected back into the computer and let's actually measure some voltages. Just a couple of errors actually I mentioned there. I said this was a Realtek chip, yeah. It's Richtek, not Realtek. I thought it was an MPS by the markings, but apparently it is a Richtek and it's not an 8611. It's an RT8811A. Yeah, somebody put them on bad caps, but by that time I'd already found the schematic. So a guy named Diff, D-I-I-F, thanks mate if you're watching this for that one, and it does match this. So we want to measure some voltages on here now, because these are so difficult to probe without shorting pins together. What I'm going to do is I'm going to see if I can find like some of these test points, which I think they are connected to the pins we're interested in, yeah. So starting from where the arrow is, the first one we're interested in is pin 3, yeah, which is enable pin. So if I look down the microscope and you can see the test meter here, pin 3 is actually there, and I think it goes to this via. Yeah. It goes to this little via here. Actually, that via looks like it's slightly damaged. There's almost like there's a break in it. Let me get in the centre, and you can see. Yeah, you know, I'm not sure that via is any good. Can you see? There's like a ring around here, and a middle bit. So we get onto the pin again. So that's the pin of the chip. You get onto the outer part of this. Got a connection. Probably I've got a connection. But it looks. I think you'll agree that looks a little bit slightly odd, but okay. So that's pin 3. That's that one. So the next one we're interested in coming round is pin 15 and 16. Yeah. So we've got to 12. So on this side. Yeah, this side is coming down to number 12, yeah. 13, 14, 15, 13, 14, this is 15. And I'm guessing this goes to here. Yeah. So I can draw this out so I know where they go, yeah. 16, what's going on here? 16 is is this one you're interested in? Yeah, so 15 is VCC, 16 is power good. So I'm also interested in 16. Does that go anywhere around here? But I think I might have a short here between 17 and 18. Can you see it? I have as well. Let me just zoom that down. You can see it now. That's a solder bridge. It's in focus for me. Let me just make sure you can see it as clear as I can see it. That's a short. So first thing I noticed, I can't really quite see where 16 was going, but 17 and 18 are shorted together. Where's 21? Well, at it. Then look at that. So up this other side then, 19, 20, 21. So 21 is PVCC. I think it's another power pin. 19, 20, 21 is here. And this looks like it goes to this via. Yeah, it does. So I can draw that as well. Now let's have a look at these short circuit pins and see what they are. Okay, so this is back to the schematic, and it looks like 17 and 18. That's these two. That's high gate 2. So that's the gate to one of the dual MOSFETs, the high side. And the other one is this one here, boot 2. I'm not sure what that pin actually does. I'll find the data sheet to this chip and see what it actually does. But what it shouldn't be doing is being shorted to here. Yeah, I'm going to remove this solder bridge. I'm going to have a look to see if this actually works then. I don't see how that's happened unless somebody's been messing with this. Yeah. Okay, so let's get rid of that solder bridge and let's see what happens then. I think we can say with a good degree of certainty that somebody's been messing with this. A little bit of flux first, and then let's sort this little mess out, and then we can a little bit of a lot of too much flux. Yeah, it happens. It happens. A little bit of leaded solder. Let me come in on this one. Let me see if I can actually. I would have to say, I think somebody's been soldering this chip. I think I've got another solder bridge now. Let me get a bit of braid as well on this, and let's see. There's the good solder bridge. Yeah. Okay. What's a fresh end on it? That's for sure. Yeah. Just get rid of that. Okay. Let's just clean this a little bit. I think it's a bit messy. You know, all said it's all just a bit messy. Yeah. Okay, that was good. While we're at it, let's look at the other sides as well. I'm not generally happy with the soldering around this thing. I mean, I don't think I see any other shorts on it. I don't think I can see any more short circuits, but just go over it. Just be sure, yeah, about it. There it is. It's a little bit difficult when you zoom this far in. It's all can get a little bit tricky. Yeah, so here we go. Let's get into your view. There you go. I have a wider field of view on the microscope than you guys through the camera. Oh, that looks nicer. Just going from the top side. There we go. Yeah, that looks nicer. And then just this last angle of the dangle. Yeah. Get into this one sideways, I think. Just do it. Yeah, I think that looks nice. Okay, I'll just clean all that up, and then let's have a look what we've got here now. Okay, so that's the chip after we've just cleaned it all up. That looks a lot better now. So very quickly just put a bit of light across it. Sometimes this can show things up here. Just use a torch. But we can see that all these pins look nicely soldered now. Yeah. I think most of them were okay, but there was an obvious solder bridge on this, and now there isn't. Yeah. So I think the thing to do with this is going to be to power this one up again, and let's see what it actually does now. Okay, let's do that. Okay, so we have this ready to test basically. We can just check again to be sure. I mean, we did test it before, but if we just go into resistance mode and check from VRAM to ground. So there's no shorts on it. Yeah, we just check for shorts from the coil to 12 volts as well. But they were okay before, so there's no real reason why they shouldn't be okay now. So that's the 12 volts on the PCIe coming in there. I've got the 12 volts coming in on the 6-way here. Yeah, that's okay. Got 12 volts coming in on the 8-way here. That's okay. Yeah, these look okay. So there's no shorts there that we need to worry about. So what we'll do is let's have a look to see if we've now got any V-core, yeah. Sorry, VRAM. I will just show you this little diagram I drew, by the way. So if we refer to the board here, there's a little wire just there, yeah, and that is pin 3, which is enable, yeah. And pin 15 is actually this pad here is a test point, which is pin 15, and pin 21, which is PVCC, it's another power rail, I think, is there on this little wire. So that's where we can just check the focus is good on that actually. Open the aperture a little bit as well, try that. Yeah. Haha, and then I messed it up. There's one moment. There you go, let's get some yes, focus. Okay, so that's all the places we can test, but before we do that, let's now just check on the VRAM and see if it's actually coming up now, yeah? So we'll put the powers on, we'll start the PC, and let's see what happens. And we don't have VRAM, just give it a chance to bleep. No, it doesn't bleep, okay. V-core, yes we do have, so V-core's still there, and VRAM isn't here, even, oops, shut down and restarted on its own. That was the PC. Even though we fixed that short, yeah, we still got no VRAM. Just a very low voltage. Okay, let's have a look at then around this chip. I'll use the magnifier, but you can see where I'm going to test. So, this is VCC, which is power to the chip. And we have 5 volts, yeah, 5 volts is VCC. The PC is restarting actually for some reason. Let's give it a chance again. So that's 5 volts on VCC. PVCC is on the little wire. I'm on it. That's at 12 volts, yeah, that sounds reasonable. And what's on enable? So pin 3 is enable, which is this little wire. That's enabled. Right. Okay. I don't think we need to go any further than that. This chip had a bridge between 2 pins, yeah. It's got enable. It's got VCC 5 volts. It's got PVCC 12 volts. Yeah, but it doesn't work. And I think there's a very good chance that this chip is now faulty, quite possibly due to that solder bridge. I may have another one of these on the scrap board. Let's have a look to see. So this is the donor board. Yeah, it's actually a 780 Ti, whereas this was a 780, or is a 780. It's a gigabyte. This is the one that actually matches that circuit diagram that I have, yeah. But it's very similar, and although some of the components look different, I'm sure you can see that pretty much this is the same, yeah. And it has the same controller chip here. So if we zoom down on this, I'll show you how the markings work on these. This is the chip there. I'll just get a bit of light on it. I'm sure you probably just make it out. So it says OT, and then an equal sign FG, yeah, whereas the other one is OT equals sign F. So the OT is actually like a code that gives you the part number. This I mentioned, same as others, a Richtech 8811, RT8811, yeah. So we can take the one from here. This donor board actually had a faulty GPU. But the RAM reads okay. These have different brands of RAM on them. This is SK Hynix, HYNIX, and this one's Samsung, yeah. So it's not unusual to find that the memory phase will read different depending on the brand. So this is our one which we hope is a good card, and this one's reading, let's get on to it, 60 ohms, yeah, and this is the Samsung RAM. This one is reading 96, yeah, and that's quite normal for Samsung to read lower in particular than other brands. This has also had a few capacitors removed as well, so make a nice donor. I think it's possible that these drivers are also the same as these ones. What I'll do is I'll change the chip. I'm going to have a look at the resistance around these MOSFETs actually. These ones on the memory phase. I may even change if these are the same, due to one effectively connected to the shorty pins here, but I think it was connected through resistors, not directly. Okay, so let's get the one off here and let's fit it onto here, and then let's see what we've got there. Okay guys, so that's the replacement chip fitted. They're fiddly things to solder these, but you know, you have to do them, don't you? So it's probably easiest to just check this without down the microscope and shine the torch against it. And also if I tilt it up slightly and then refocus, there we go. That probably gives you a good indication that this is soldered properly. So you can see down this side, and this looks okay. I've got a bit of solder on one of the test pads, but that really isn't a problem. Yeah, let's go again on this side. So again, they look like they're soldered okay. Next to the end one, just have a look. Yeah, I think that's okay. The one where the solder's gone to the test point again. Yeah. We can just come down this side, get some bit of light in again, and then tilt the board up a little bit. Okay, I've rated to a good angle. Let's have a look. Yeah, that seems okay. And then the last one down this side. And again, that seems okay. So it looks like I've got them all soldered. I mean, it's not totally possible to tell to do it this way, to be quite honest. Now, there's certainly no solder bridges, and it's the right way round, so the dots by the arrow. So it's always worth making sure it's the right way round, yeah. No, I think that side is okay. As I say, the only way to really tell with this is to try it, yeah. So there's certainly no solder bridges on it. So let's give this a go. I've also just checked. So these are the two MOSFETs, yeah. Now the short was on one of them, on the high side MOSFET. It was effectively between the gate and the sense input coming back. If I just go over to the circuit diagram, I'll actually show you where the short actually was. Okay, so we had a short here between 17 and 18. Now you can see that there's a capacitor here, yeah. So although this was bridged, the gate was effectively bridged to here. This is an input, and it goes through resistance and kind of goes nowhere. So I don't think it's caused a problem with the MOSFETs. I've checked from the gate of both of them to ground, and the same on the other one to ground, and they read the same, yeah. So they were very, very high resistance, it's practically open circuit. So I don't think I've got a problem there either. You have to come to a point with this sort of thing when you think, okay, well, it's good enough, you know. So let's try it and let's see if we've now actually got any VRAM on this board. Okay, so that's all set up, ready to go. I've got the little adapter thing on it again, so I've got the ground clipped on just to make it easier, really. Yeah, so let's get onto the memory phase, and let's just power this up now and see if we actually have VRAM. Yeah, so power supply is on, and we'll hit the start button and let's see what it does. Well, first of all, I've got the current limit on the power supply. It didn't like it. It wasn't on. It was just, I was just testing something for somebody previously. I left it switched on, so I think the power supply just didn't want to power up then. Come on, switch, stay on. Okay, everything working. Yeah. Okay, so let's see what we get. Well, it came up and went off again. Power supply switch on my Variac. Okay, power's on again. So here we are on VRAM again, yeah, but I got some voltage here. Let's power it up again. I'm not happy about that. It shouldn't be doing that. It's like it came up and goes off again. I don't think it's a short anywhere. I'll just check. Alright, yeah, so what's happened here now is, this is why it went on and off again. I didn't bother to write it again after that second time of that, is these MOSFETs, which are driven by this chip, are now have gone short. So this board's definitely got some problems in this area. Yeah. The thing that worries me a bit more than that is the fact is the VRAM is now reading like 2830, yeah. So what I'll do is I'll take these two MOSFETs off, and then let's see what the RAM is reading now. I mean, previously it was reading about 60, yeah. So I mean the V core, that's still reading where it was, about 5, yeah, 5.9, about 30, yeah. Okay, let's get these MOSFETs off. Okay, so these are our two MOSFETs, and I've drawn, this is the layout, so you've got drain 1 and then source of 1 and drain of 2 are connected together on this pad, and this is source 2 and these are 2 gates, yeah. So if we have a look, let's put it onto diode mode, meters and diode mode now. So what you should have is from the drain 1 to source 1, so that's across here to here, yeah. That one's reading short. This one reads open. So this is reading okay, yeah. Now if we want to check the MOSFET, if we touch the positive lead to the gate, which is here, it should now switch on. Yeah, it's now switched on, yeah. And if we touch the negative lead to the gate, just do it there, yeah, it should switch off. Okay, and then we can do the same with the MOSFET. So red on the drain, black on the source, and it should be open circuit, yeah. Red lead, just touch the gate and then come back, it's now turned on, yeah. If we touch the black lead to the gate, it'll switch off. So that's a good MOSFET. Here's ours, and we know already this is faulty, yeah. So to be sure, read from here, but it's the same. This is drain 1, these are drain 1, yeah, it's the same thing. That's on. Touch the black lead to the gate. In fact, the gate's short. Yeah, sort of short on the gate. Yeah, so that's short, that side. Which would be the high side, it's this side of it, yeah. The other side, we can have a look, so it's open circuit, yeah. Touch the gate. Let's see what will turn on. Yes, that MOSFET's good, it's turned on now. Black lead to the gate, turned off again. So one of these now has a short circuit high side MOSFET. Now I checked the resistance from the gates before to the chip after I fitted the chip, and they were both the same. So this has somehow caused that MOSFET to go short circuit. If you look on the card, I've checked this before, but I've just checked it again. Let's go on to resistance mode, yeah. So this is obviously your phase for your RAM. This is your V core. So V core to ground is reading ohms. about 5.6. Yeah, I mean that's reasonable still. Yeah, and the VRAM is reading 57. That's practically what it was reading before, about 60. Yeah, so I suspect maybe that it's actually survived this. Hopefully, yeah. So what I need to do now is replace these two MOSFETs and replace this with a new one. I'll just check what I've got in stock. Okay, so I don't have the MOSFETs in stock, and I think that was the only one of the RT881 I happened to have on the donor board. But let's have a look on AliExpress. We can just go over there now. So the RT8811As are quite inexpensive. You get like 5 for €4, 5 for 385 here. We can have a look. Yeah, 385 plus shipping, but including 20% VAT, which I don't pay, by the way. So it'll be about €4 for those. So I'll order a pack of 5 of those. It's going to be useful. The other one is the 4901 NF. Yeah, let's see how much these are. Okay, so again, 5 for about €2, 10 for €4. $4.59 in sale price with free shipping. So those are going to cost me less than €4 because again I don't pay the VAT. So I'll order the parts for this one. I'm quite sort of, well, I wouldn't say confident, but I'm happy to see that the resistance of the RAM hasn't really changed, and the resistance of the GPU hasn't really changed. So with a bit of luck, replacing the MOSFETs and fitting the new chip with this one might get it. I mean, it did come up, or tried to come up before. You just one went short. Yeah. Okay, guys. So a failed attempt, but educational stuff all along. I'll get them ordered now. Probably turn up in December, and let's do a part 2. Okay, got plenty more graphics cards to look at. So let's hope for a bit more luck on the next one. Ciao for now, guys. See you soon.